In this video, we're going to cover an AP Physics C free response type of question. This question is related with the Newton laws of motions. So in this problem, we have Atwood's machine. Wood's machine. So in this, we have two blocks. One block we'll call M1, one of these blocks call M2. So basically these two blocks are connected by a light string over a frictionless pulley. And in this example, we're going to have mass 2 will be greater than mass 1. So this should tell you the direction in which these two blocks will move. So in this problem, the first part, I want you to draw a free body diagram for each block. And so I'm going to draw 2 points. We'll have one for mass 1 and one for mass 2. Once you draw a free body diagram, and the relative lengths of your arrows should show the relative magnitude of your forces. Then, for part B, I want you to apply Newton's second law for each block. So for mass 2 and mass 1, and come up with an expression for acceleration that only uses mass 2, mass 1, and g. So come up with an expression for acceleration. So here I would like you to pause the video and work out these two parts of this problem on your own, and then unpause the video and we'll go through the solution. Okay, so for mass 1, we have two forces acting on mass 1. One will be the tension force of the string, and one will be the force of gravity on mass 1. So we'll have Ft, which will just force tension, Ft. Now, since mass 2 is greater than mass 1, the block will be moving in an upward position, which means that this tension force has to be greater. So we'll draw this one smaller than Ft. Draw that a little better. Okay, so this is Fg of mass 1. And so that is a free body diagram of mass 1. So here, one of the things is having these two forces and drawing the arrow of the force of gravity smaller than the force of the tension. Now in mass 2, this tension force is going to be the same magnitude. So let's draw this arrow approximately the same length. This one, again, is F of t, which is the same for both blocks because they're connected by the same string. And here, mass 2 is greater than mass 1. So this system, mass 1 is going upward and mass 2 will be coming down. So the force of gravity for mass 2 is greater than the tension force, Fg2, which is also M1g, and for here, this is equal to M2g. Okay, so now apply Newton's second law for mass 2 and a mass 1. So if we, okay, so I'm going to work through the part B down here. So for the first block, we have our tension force, which will be a positive value. And then our force of gravity is in the downward direction. So assuming that G will be just a constant value, and usually G we have as 9.8 meters per second squared, but here we'll just write as G minus m1g is equal to mass 1 and the acceleration of block 1. So again, with the Newton's second law, basically that says force, the sum of the forces, terrible sum. Before the forces is equal to the mass times acceleration on an object. So here we've got two forces acting on our mass 1, and that's equal to mass 1 times acceleration 1. For the second block, we also have Ft minus m2g equals, now for the second block, the mass is m2 and acceleration of 2. Now, they both have the same tension force, and they'll have the same magnitude for acceleration. The only thing different about the acceleration between the two blocks is that here, acceleration's upward, and here, the block is accelerating downward. So the relationship between acceleration and acceleration 2 is that a1 is equal to negative a2. And so what we can do, so now we basically have an a system of two equations with two unknowns, and we want to solve for A just with these three variables. So we want to get rid of the tension force. So I'm going to substitute A1 here. So we'll have this is equal to negative m2 A1. So then I'm going to multiply this whole equation by negative 1. So we'll have negative Ft plus m2g is equal to m2a1. So basically I just multiplied this equation right here by negative 1. And the reason I did that is that I'm going to add it to the first equation. Ft minus mass of 1 g equal to mass of 1 a1. So then I'm going to add these two equations together. And so our tension force cancels. And here, so let me see if I can get rid of this. Okay. So then we'll have negative m1g plus m2g equals m1 plus m2 a1. So a1 equal to m2 minus m1 times g all over m2 plus m1. And this is the expression for acceleration for block 1. And as you can see, this will be a positive value because m2 is greater than m1, g is 9.8 on Earth, and this is also a positive value. And so the acceleration of the block A2 is just the negative of A1. So here is the magnitude for the acceleration of each block. Okay, so that was Atwood's machine. So just a little background, this machine was invented by a mathematician as a lab experiment to verify the laws of motion with constant acceleration. So what they would do is have this system, and they would vary the mass of these two blocks and measure the acceleration. And then what they would do, as you can see in this expression, they would plot on the y-axis the measured acceleration, and then on the horizontal axis they would have this expression m2 minus m1 over m2 plus m1, and then the slope of the scatter plot should be very close to 9.8, which is the acceleration of gravity on Earth. So that was Atwood's machine. Now I'm going to go over half Atwood machine. So I'll go over that in the next video. Thanks for watching.